box out. Nice.
What's going on, sir?
What's up, man? Oh. Any questions before we begin?
Yeah. Could we work on 11.3, question 11?
Is that you, Roman?
Yes, sir.
All right. 11.3, question 11. All right, let's see.
Though really the only thing that gets me is I think it might be a perfect circle, but like I don't really remember what to do once like I have A, but B is 0, and then like I have them all, and then I don't really remember because it's like it doesn't favor an axis. It hits them both, so I was kind of confused on that end.
Oh, that's tricky.
And then would it be under the assumption that since it's containing point 1 3, would that be the MP?
Yep.
Okay, so
That's what we're
all
gonna
right,
have
for
to
sure.
assume. Yeah.
Yeah, okay, for sure. Yeah, then I was kind of
So we're at 1, 2, 3, 4, 5, and then 1, and then center is at 1, -1. Vertex is at 5, -1, right? That's the first vertex, which means that's 1, 2, 3, 4 spaces away, which means you could find the other vertex, right?
yes.
5. So that's 4. So 1, 2, 3, 4, and then 1, 2, 3, 1, 2, 3, 4. There would be vertex 2. Here's center. And then, yeah, we're going to just have to assume that that is the minor point at 1, 3. 1, 2, 3. So that's going to be a minor point. Okay, which means that A is 4 and B is what?
4.
Is that 4 as well? 1, 2, 3, 4. B is 4.
Okay, so that's what I was confused on then, because I put C was 4, but it was supposed to be B.
Gotcha. Because remember, A is the distance from center to vertex. B is the distance from center to minor point. And then C is the distance from center to focus.
Gotcha.
Yeah. And C squared would be A squared minus B squared. So there wouldn't be a focus then, right?
Yeah.
So that would be at 0. Because then to find that one, 1, 2, 3, 4. And I think we'd have a circle, right?
How would you write that into an equation? I mean,
So
I might have over complicated it, but
no. Let's see. I would have x minus 1 squared over 16, right?
yes.
Plus y plus 1 squared over 16 equal to 1.
Okay.
Then you can like multiply 16 onto both sides, and that'll give you the.
Yes, for sure. But I think it still wants it as an ellipse, though, right? Or no?
Well, okay, so at
Well, yeah,
first,
that's what I was wondering because I thought that equation is for like if your point is at 0. Like if your center is at 0, 0, that you would use the x minus h or whatever.
Well, no,
And
if your point is at 0, 0, then your x minus h would be x minus 0 squared. So it would just be x squared and y squared plus y squared.
no, no, that's why I was wondering. Never mind, never mind.
Yeah, because you could rewrite this as x minus 1 squared plus y plus 1 squared equal to 16, but is he going to take either answer?
It took only one for me, but I don't remember which one it was. I think I tried writing in the ellipse the first time because it wanted it at first, but it didn't take that one. Or no, I tried writing in the circle equation and that one didn't work. And
Didn't
it
take.
went
Yeah, I'm looking. The equation for the ellipse whose center is there, and this is equivalent to the standard form of a circle. I'm assuming since this is ellipses, it's going to take the ellipse answer.
through.
Look at that circle.
Vertebra.
Perfect.
Thank you.
Yep. Makes sense, Roman?
Yes, sir. I was just, I guess, like thinking too much into it or something.
Yes, Maria. This is number 11, ellipses, which this one is a circle. But yeah.
Like what I didn't do is I like really didn't take into account where everything or like where all the points were. So like when it gave me that point, I was like working all these like super complicated. And I'm like, well, if I'm getting 4 and I'm getting 4, then,
Yeah,
Yeah.
no, I was with you because I was like, well, it's a perfect circle, but we're working on like ellipses. So I was like,
yeah. But
Yeah.
and it was 2 questions that it did it for me. So it was just like, I guess trying to like catch us, or like test us
And
on it.
it's also that wording of contains the point 1-3. Like how and why are we supposed to make the assumption that's a minor point, right?
Mm-hmm.
It's just something we have to assume.
Because it's directly above. It's the
Above.
point directly above. And
Yeah.
yeah, so then it has to be the minor point.
Yep. What does this say about? Let's see.
Can we do another one just for the heck of it?
Okay. Let me see. Like something of the same?
Yeah. Yeah.
We'll call this Bizarro number 11. Why not? Here I have a center at 2, -1. I've got a vertex at 2, 7. And then we contain the point 10, -1, which we're going to assume that that's a minor point, right? For now. Or just, yes. Okay, so if I were to graph that, we go out to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then go down to 1 and up to 7. 1, 2, 3, 4, 5, 6, 7. And my center is at 2, -1. My vertex is at 2, 7. So up there. Vertex 1, which means if that's there, that's 1, 2, 3, 4, 5, 6, 7, 8 spaces away. So that means that A is 8, which means you can find the other one by going down 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. And there would be vertex 2. And then we're assuming that my minor point is 10, -1. So to the right. And if that is 1, 2, 3, 4, 5, 6, 7, no. 5, 6, 7, 8 spaces away. That means B is 8. And then that means you go 8 spaces to the left. 1, Well, first, 1, 2, 3, 4, 5, 6, 7, 8. And here would be my next minor point. And all we have to do is connect. But since the center, because this, well, first off, C would be 0. And then since the center and the vertices are parallel with the, actually, it doesn't matter at all, right? You'd
Nope.
have x minus 2 squared over 64 plus y plus 1 squared over 64 equal to 1. There we go. Yeehaw. Be right back. Can't hear anything. Hi, here. Howdy. Yeah. Okay. Cool. Any other questions before we do hyperbolas? Which I should post those notes in the chat. Pre-cal. Meet cars. Hyperbolas. Cool. There you guys go. Those are the notes we're covering today. All right. Seems like everybody's good to go then. Okay. Here is our last conic, the hyperbola. And it has similar things to the ellipse. It's basically you split the ellipse in half and inverted the sides, right? So here is our hyperbola, the set of all points in a plane for which the absolute value of the difference of the distances from two fixed points, the foci, is constant. What? The midpoint of the segment between the foci is the center of the hyperbola. So here is our hyperbola. So just like ellipses, you have two vertex or vertices. You have two focus or foci. And something not shown here is minor points. So I'll have minor points up here on the conjugate axis. So above and below the center. And then the axis containing the vertices and the foci in the center is called the transverse axis. So here's our minor points. Okay. Another cool thing that's not shown is called the fundamental rectangle. So if you connect your minor points to your vertices, you will always create a rectangle. And another thing not shown is that these hyperbolas have asymptotes. And what's cool about the fundamental rectangle is that your asymptotes will go through each corner and the center of your hyperbola. And your hyperbola follows along those lines. If I can get it straight enough, but you get it. So there we go. And again, just like ellipses, some things are the same. The distance from center to vertex is A. The distance from center to minor point is B. And the distance from center to foci is C. Those are all the exact same things as an ellipse, right? Exact same.
But
Okay.
this time it would be that A would be the smallest number.
This time A is smaller than definitely the foci, right?
Yeah, definitely the foci.
Yeah. It would depend on where the minor points lie to see whether A or B would be bigger than each other.
Okay.
Yeah. So just like I stated below, A is the distance from center to vertices, B B is the distance from center to minor points, and C is the distance from center to foci. And just like ellipses, if you know A, B, and C, and you know what axis you are parallel to, you will know which equation to use, and all the pieces will come together. Okay, but of course, we have more formulas. So if you are parallel to the x-axis, your center is still HK. You'll have foci, vertices, minor points, and here's our equation of the hyperbola that is parallel to the x-axis. You have x minus h squared over a squared minus y minus k squared over b squared equal to 1. Now tell me, what's the only difference between this formula and the ellipsis formula?
Minus and plus.
Minus and plus. If you change this to a plus, you have an ellipse. If it's a minus, you have a hyperbola. Nothing crazy, right? And then if you need to find any values of a, b, or c, we again use Pythagorean theorem. So b squared equals c squared minus a squared, or I'll just rewrite that out here. If you rearrange it, it's the same as a squared plus b squared equal to c squared. Okay. And then we're going to have the asymptotes. So we're going to have to find the asymptotes that cut through that fundamental rectangle. And it's what our hyperbolas follow. So if you are parallel to the x-axis, you have y minus k equal to plus or minus b over a times x minus h. And then if you're parallel to the y-axis, now look at the differences here. Y minus k squared is now in front over the denominator of a squared, and then x is the negative 1. So you have y minus k squared over a squared minus x minus a squared over b squared equal to 1. The Pythagorean theorem formula is still the same to find a, b, or c. And then for your asymptotes, there was one notable difference. So if you're parallel to the x-axis, it's b over a. If you're parallel to the y-axis, it's going to be a over b. And once again, to make these formulas really simple, if you know A, B, and C and what axis you're parallel to, everything will fall into place. Now, let me erase all these colors, except for that piece. Okay. Here are more pictures of what horizontal and vertical hyperbolas look like. So your horizontal, if you are parallel with the x-axis. So here's a transverse axis, the one that carries the center, the vertices, and the foci. It's parallel to the x-axis, so your hyperbola will open left and right. And I guess you can make a comparison to parabolas here, because remember with parabolas, based on the placement of your focus, told you how your parabola was going to open. So look at this. This focus is to the right, and this hyperbola opens right. This focus is to the left, and that hyperbola opens left. And if you are horizontal, your formula is x minus h squared minus y minus k squared. And then for vertical, your transverse axis is parallel with the y-axis. It carries the center, the vertices, the foci, and again, you can make your comparisons to parabolas. Here, the foci is above the vertice, so it opens up. Here, the foci is below, so this opens down. And if you have a vertical hyperbola, your formula is y minus k squared minus x minus h squared over all that good stuff. All right. So these are the formulas we're going to use. Yay, lots of formula. That's what pre-cal's about. Wait till we get to trig. There's going to be like 30 more formulas for us to learn. Yeehaw. Okay. For now, we get the conics out of the way because, again, the reason I teach conics first is because it's one big algebra review. Because we've just been completing the square to create formulas and just piecing things together. Okay. So on the next page, once again, here's the formula box so we can reference this while working this problem. And this says, find the equation of a hyperbola. Find an equation for the hyperbola with the center at 1, -2, one focus at 4, -2, and one vertex at 3, -2. And just like every other conic we've dealt with, one of the easiest ways to find A, B, and C and find what axis we're parallel to, plot everything they're giving us. Plot all the clues. So, oh, I shouldn't have put that graph so low. Oh well, that's where it ends. Okay, so with that being said, that's good. I'm going to plot the center at 1, -2. So 1, -2. There's my center. Let me make that a little bigger. 1, -2, which is down there. There's my center. And then my focus at 4, -2. 1, 2, 3, 4. -2. So there's center, there's focus, and a vertex at 3, -2. So 1, 2, 3, and -2. So let me just label these center, vertex, focus. And now I can zoom in. There we go. Make this a little prettier. Center, vertex 1, focus 1. Okay, well, some things are given already. What is the distance from center to vertex?
2.
2. We don't know B yet, but we know C. What is the distance from center to focus?
3.
3. Good. And in order to find B, well, we just look for B. We'll use the Pythagorean theorem, and it's going to be B squared equals C squared minus A squared, which will give me B squared equals 9 minus 4, B squared equals 5, and we're going to get B is the square root of 5, which was what, like 2.1? No, 2.24. Okay, so we know A, B, and C. This means, can we find the other vertex, the other focus, and the minor points?
Yes.
Yeah.
The other vertex would be 2, but to the 2 away from the center, but to the
Right
left.
there, right?
Focus would be 1 more past that. To the left.
And then the focus would be 1 more past that, right? And there'd be focus 2. And then my minor points are at, we go up 2.24 from the center, 1, 2, and I'll just put it there. And then down 1, 2, 2.24. There's my minor points. And before we continue, like I said, what's important, find A, find B, find C, and then find what axis you are parallel to. What axis are we parallel to?
The y-axis?
So the line carrying these,
Oh, okay. So the x-axis.
we're parallel to the x-axis.
It kind of throws you off because it looks like the axis intersects the actual parabolas themselves.
Oh, I hear what you're saying. Yeah. Okay. So if we're parallel to the x-axis, well, we know what the center is, which means we know what formula we can use. We're going to use this formula, x minus h squared over a squared minus y minus k squared over b squared equal to 1. And for our equation, well, we're going to have x plus 1. X plus 1 squared. A is 9. No, A is 4. X plus 1 squared over 4 minus y plus, we go down 2 over b squared, which is 5, equal to 1. So there's the equation of our hyperbola. And now to graph this, I'm going to connect the minor points to the vertices and create my fundamental rectangle. And now we know which way our hyperbola will open. Since this focus is to the right of that vertex, this means we're going to open to the right.
I'm sorry, could you say that again?
So the way your hyperbola opens is based on the placement of the focus. So since this focus is to the right of that vertex, we're going to have a hyperbola that opens to the right. And over here, you have a focus to the left. So we'll have a hyperbola that opens to the left.
So same concept we had with the 11.2. It's just you have two parabolas now, basically.
Exactly. All right. So we have all of our components. Let's go ahead and label everything we have, and let's go ahead and find those asymptotes. So down here, all right. So I'm going to say that well, first they give us the center. They gave us the center at, oh wait, should I have -1 there instead of +1?
Yep.
We have the center at 1, -2. We have the vertices. I have one at -1, -2. And then I have one at 3, -2. And then my foci, which are nice, are at, what was that, 1, 2, 3, 4. I'll start with the left side. -2, -2, and then 4, -2. And then my minor points, since they're ugly, I can write this as 1 and -2 plus or minus the square root of 5. And the last thing to find is the asymptote. So I'm going to say for my asymptotes, we have that formula y minus k equal to plus or minus b over a times x minus h. So plug in k value, b value, which was the square root of 5, over a, which was 3, right? No, 2. A was 2. Times x minus 1. Let me just make sure I have those right. That's b over a. Yeah, so b was the square root of 5. Okay. And then we'll get y plus 2 equal to plus or minus square root of 5 over 2 times x minus 1. And I believe it doesn't make you solve for it anymore. But if it did, that would be nasty. Anybody want to explore that?
Way ahead of you. I'm still doing it.
Yeah, let's look at that. We have the time. Let's say you had to expand this more. Then that would be y minus 2 equal to, well, I'll have a plus route first. So let's say I distribute that square root of 5 over 2x minus the square root of 5 over 2. Add that 2 over, square root of 5 over 2.
Why minus 2?
It's plus 2.
2
did I
plus 2. You put a minus instead of a plus on the y minus 2. Top left.
Good. And square root of 5 over 2 minus 2, which means I would need to combine those into one fraction, which we would get y equals the square root of 5 halves x minus, and if you did that, put 2 over 1 multiplied by 2 over 2, you would get the square root of 5 minus 4 over 2. And that would just be for the plus route. Because you have a plus or minus on that square root of 5 over 2. I'm assuming that you could probably still keep this plus or minus though, right? Because then that would be negative. Yeah, maybe you could have plus or minuses on both. Let's see. Because that was plus, and if I go minus, that would be y equals negative square root of 5 over 2x. And then if that was negative, that would be positive square root of 5. And that would still be minus 4 over 2. But like I said, I don't think my math lab is going to make you solve for y. But if it does, that's what it would look like. Just awful. Okay. Any questions on that one? So if you know the components they give you, if you know A, if you know B, if you know C, and you know what axis you're parallel to, everything falls into place. Everybody good with that?
Yes, sir.
Okay. Okay. With that being said, you guys go ahead and try this next one out. Vertices are at negative 4, 0, 4, 0, and they're giving you the asymptote already of y equals 2x. So that is going to be a clue to help you find, I think, the value of b. Ooh la la. Cool. 40 and 40.
Why did you set equal to 2, sir?
Because what's the asymptote it's giving us?
Y equals 2x?
Yep. And what's the coefficient there?
Wait, 1 second.
1/2
Well,
x?
so it's 8/4. But okay, so would that make C a negative number?
No.
Well, I mean a negative. Well, you can't really have like the.
Because remember, if we're using a squared plus b squared equals c squared.
Okay, a squared plus b squared. Okay.
You good, Ethan, or no?
Honestly, not really.
So they gave us A by giving us the vertices, right?
Right.
So now we plot the vertices, we get the center, but now they're also giving us the asymptote. So since we're parallel with the x-axis, this is the formula we would use for the asymptote, right?
Right.
But since the center is 0, 0, you are left with, I guess maybe this might make more sense. You're left with y equals plus or minus BAX. Now,
Okay.
if there's this BA and there's this 2, could you not set them equal to each other to solve for B?
Okay, that's where you got that. Okay.
Because then, after that, what is the value of A?
Well, the value of A is 4, so you said
So,
equals to B over
so
4.
you plug it in there, then you multiply by 4 and you get B equals 8.
Okay.
Better?
Yeah, that's, yeah.
All right. Okay. And then square root of 80 is 4 square root 5, or better yet, 8.94. So
Yes, sir.
What's up?
I said yes, sir.
Oh, yes, sir. You said, sir. What?
Ah,
All right, so that means for my vertices, I go out 8.94 to the right. So I'm just going to go out to 9. So here's for, I mean, never for focus. There's that one. There's that one. And you have focus 2, focus 1. And then my minor points go up 8. So that's going to go there and then there. And there's my minor points. Make my little fundamental rectangle. Doot, 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 doot. And we know that our asymptotes cut straight through. So if my asymptotes are y equals 2x, hey, this is fun. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1.
Negative reciprocal.
There we go. There we go. There we go. Well, not negative reciprocal, just plus or minus, right?
Oh, true. Well, oh yeah. No, I got you.
Because if they give us an asymptote at 2x, this means we also have an asymptote at
Negative 2x.
negative 2x. There you go. And I would come down like this. I don't think we have to draw the asymptotes, but if we do, that's not too bad. And my hyperbola is horizontal, so this means it will open up into the right, down into the right, up into the left, down into the left. And now all we have to do is label everything we have. First off, starting with the equation, I'll have x, actually just x squared, right?
Yes, sir.
X squared over a squared, which is 16, minus y squared over b squared, which is 64, equal to 1. There's our equation. And now let's just go ahead and label everything. Center is 0, 0. Vertices, they gave that to us already. Negative 4, 0, 4, 0. Foci are nasty. So I can just say plus or minus 4 square root 5 and 0. Minor points are at, I can do this, 0 and plus or minus 8. And they give us the asymptotes, but I'll rewrite them anyways as y equals plus or minus 2x. And there we go.
Can't wait till we get to the real world problem.
For hyperbolas,
Mm-hmm.
if we have any, did I put any on here? Nope, just application.
Yes.
Okay. All right. Everybody good with this one?
Yes, sir.
Yes, sir.
2 yeses out of 20. I'll take it. What's everybody watching? Mass Singer right now? Okay. Let's keep moving then. So this time we're given general form. Now let's put it in the standard form. And of course, we're going to do that by what process?
Your favorite, completing the square.
My favorite. You're right. I do like it. Quadratic formula. Get out of here. Okay. So I'm going to rewrite this. Since y squared is positive, I'm going to write that one first and combine it with the y's. So I'm going to rewrite it as 4y squared minus 16y, and then I'll write my x squared minus x squared minus 2x, and what am I moving over to the right?
11 to negative
11. There we go. Okay. And now we want to complete the square, but we can't do that unless the leading terms are positive 1. So what can I factor out of the y's?
4.
We're going to take a 4 out. That'll leave me with 4 times y squared minus 4y. And what can I take out of the x's?
-1.
A negative 1. And that'll leave me with x squared plus 2x equal to negative 11. All right, just making sure I did that right. And now we are ready to complete the square here. CTS, boom, boom, boom. We're going to take half of 4 and square it, and I'll get negative 2 squared, which gives me 4. We're going to do the same here. We are going to take half of 2 and square it, which is going to give me 1. Okay, so let's go ahead and rewrite this. I have 4 times y squared minus 4y plus what number?
4.
4. And then minus, I don't need that 1 there anymore. Actually, I'll put that 1 there still. We'll need that for now. X squared plus 2x plus what number?
1.
1. Good. Equal to negative 11 plus what number?
5.
16. Remember, this 4 and that 4.
Oh yeah, I always forget that.
If that 4 wasn't there, then yes, it would just be 4. Plus, what are we going to have here?
Negative 1.
Negative 1. Good. Because this negative 1 times that 1 gives me that negative 1.
I always forget those outside numbers.
It's killer, man. It's killer. Okay. So now let's go ahead and factor, and I'll get 4 times y minus 2 squared minus, now I can get rid of that 1. I just put the negative in front, and this will be x plus 1 squared equal to 4.
Yep.
Yeah. Okay. And now we need to put this into standard form still. So we're going to divide everything by what number?
4.
4, 4, 4. And what is the only number to remember?
4?
4. That lawyer guy, right? Fine.
No idea.
No fun. You don't watch enough TV?
And is it like 444?
I haven't
and
watched
he has,
TV
like,
in forever.
4, 4, 4, 4. The only number to
Yeah.
remember is 4.
I'm uncultured.
No, you don't need to know that. Anyways, all right. Hey, and look at this. We finally get an equation of the hyperbola that is parallel to what axis?
That'd be parallel to the y-axis, right?
Yeah.
So is it gonna be parallel to whichever if the y or the x is on the left?
Whatever's leading and whatever's
Parallel
positive.
Leading? Yeah.
to the one. Okay, so whichever one is negative is gonna be parallel to the other one.
I guess that makes sense. Yeah.
That's like the way I'm remembering. I
Or
say it so badly though.
whatever the leading term is and whatever's positive, right? So here, y is the leading term and y is positive.
Yes, sir.
Okay. So we're parallel to the y-axis. So now we can actually give some information from this. So if you compare this to the formula above, what is the value of A?
1,
What's the value of B?
2.
2.
2.
And then it's a squared plus b squared equals c squared, right?
Yep. So to find C, a squared plus b squared equals c squared, and you'll get 1 plus 4 equal to c squared. We'll get 5 equal to c squared. And again, we'll get the square root of 5.
Why can't they just be
1
nice
plus
numbers?
16?
What's that?
Wouldn't it be 1 plus 16 because 4 squared? Or
Well, no, b is 2.
Oh, okay.
There you go.
Yeah, I have that written down. I was just like looking at your Okay. Yeah, I don't know.
2.24. Yeah, I always wonder why these can't be nice numbers either. Maybe because it'd be too easy.
Right?
All right. And now, some other important pieces of information. One that we can gather already. What's the center going to be?
-2, -1.
Would it be 2, -1?
No.
No. Negative
Hey,
1,
-1,
2.
-2. Sorry.
Negative 1,
Negative
2.
1, positive 2.
Positive 2.
Yeah, because it's y
It's the
minus 2.
opposite of the 2.
No, you got that wrong.
Did I mess up a sign up here?
Yeah, so y, okay, it's y, yeah, okay, so wait, was it y minus? Oh, it was y minus
It's
16.
y minus.
Okay, so
You just told me I messed up. Okay. So
We got
there's
it
my
right like after
center.
the 50th time.
Yeah. -1, 2. There's my center, right? There's the center. And now, since we know A, B, and C, we can find everything else because we're parallel to the y-axis. So to find my vertices, I'm going to go up how many spaces from the center?
2?
Just 1. Because A is 1, right?
yes, sir.
Actually, I need to zoom in because that's ugly. I'll just leave that there for now. Let me see. Because since A is 1, you go up 1 from the center, you go down 1 from the center. And then to find my foci, we're going to go up 2.24 and down 2.24. 1, 2. So that's going to be like there. 1, 2, and it's going to be right there. All right, let me zoom in. All right, B is 2. Just remember that.
So it's going to be left or right 2? Is that what you mean?
Yeah. Since I zoomed away, just remind me if I forget. There's the center. There's the center. There's vertex 1, focus 1, vertex 2, focus 2. And then I go right 2, left 2. And there's my minor points. Fundamental rectangle, minor 2 vertices. Oops, too far. And then, right, that's 1, 2, 1, 2. And then I'll just draw my asymptotes. We don't know them yet, but we know they cut through the center. And the corners of my rectangle. And since my foci is above and below, we open up, we open down.
So it would be y minus k plus minus a over b, right?
Yeah. A over B, yeah. Okay. So there is my hyperbola. So I'm just going to fill out the rest of what we know. And that's ugly looking. So maybe I can make that prettier. Let's see. Center, we said is at -1, 2. Vertices, we're at, the center stayed there, but we went up 1. So 3, yeah. 1, 2, 3. And then we went down 1. So -1, 1. Foci were the ugly ones. So this stays as -1, but I can put 2 plus or minus the square root of 5. Minor points, we're at 1, 2, 3, 2. So -3, 2. And 1, 2. And then for the ugly ones, the asymptotes, y minus k equal to plus or minus a over b times x minus h. Plug in what we know, y minus 2 equal to plus or minus a, 1/2 times x, and this is just going to become plus 1. And like I said, I think you can leave it like that, but if you want to solve for it, go ahead.
Let's do it.
Let's do it. And there's that. Yeah. If you wanted to expand that, I'll say for the plus, you'd have y minus 2 equal to 1/2 times x plus 1. Y minus 2 equals 1/2 x plus 1/2. Add the 2 over, and 1/2 plus 2 is that 3.5? No, that's
Should be 5 over
2.5.
2, right?
5 over 2. Sorry. And then for the minus, you would just have, what would change? That would just be y equals -1/2 x. And if that's -1/2 plus 2,
That should be the -3/2.
I think positive, right?
Oh, yeah.
Positive 3/2. There you go. Yeehaw. Wonder if that's true from there. That's 1/2. Up 1, it is. Over 2. Down 1, over 2. And
Yeah, that should be
1.5
right.
and
That's what I
2.5.
got.
It's pretty accurate. My graph. Nice. Okay. Any questions on that one?
No, sir.
How about from anybody other than the two people answering? Everybody good?
Yeah.
All right. There's Roman. All right. Jessica, I don't know about that one. Okay, let's move on.
That's so messed up.
Yeah, I think I'm gonna have to rewatch the YouTube video.
All right. Did you have any questions over some of it?
No, I'm good.
Okay.
This seems actually more simple than ellipses for some reason.
Yeah, I don't know. They're just conics. Okay. With that being said, this is the last one for the day. So go ahead and try it out. And if you have questions on any previous ones, let me know. No questions until doing it. Okay, cool. Good. Good. It's good to hear.
C is going to be the distance from the vertex to center, right?
C is the distance from center to foci.
Okay.
Okay, let me jump in.
Okay, I have a quick question.
Yeah.
So it says that the asymptote is 3/2, right?
Uh-huh.
So that, okay, well, so I got that it's parallel to the y-axis because of the vertices. And then, so using the y+1 and the x-1 from the asymptote, I got
Mm-hmm.
that the center is 1, -1. But
Mm-hmm.
so if it's parallel to the y-axis, wouldn't it be a over b?
Uh-huh.
So why is it 3/2 then? If
Ooh, that means you have to solve for B, right?
oh, okay, Dang it! I was hoping it made it easy.
That's what I was just gonna ask you. Would you have to do that same thing where you solve for it and set equal to it?
Exactly. You're gonna get something funky too. 1 negative 3 1 1.
Wait, solve for what exactly?
Hang on,
For-
I'm getting there.
okay.
Well, you know A, so now you have to
Yeah,
find B.
2. A is 2.
Yeah, I'm having problems too.
Oh my goodness. Okay,
Decade.
so hang on, let me look at this. Well, I'm looking at different screens. Okay, so they're giving us that the asymptote is y plus 1, 3 halves x minus 1. So this means we are parallel with the y-axis. You guys figured that out, right? So
Yeah.
now we're going to say find B using the asymptote formula again. So for if you're parallel to the x-axis, this means that you have y equals plus or minus a over b, right?
Yes, sir.
Yeah.
Okay. Well, what they're saying is that a over b, according to the asymptote, is what value?
2. Well, A is 2.
Well, now I'm not asking for what a is. I'm asking what is the a
Yeah,
or b.
yeah. The value of there is 2.
A over b is 3 halves. Following me now?
Okay. Yes.
So now the only value we know is 2, right? I mean, is a.
So
Which is
so it's
2.
gonna be 2 over b equals 3 halves.
Yep. And
Oh, okay,
now
that's
solve for b. You'll get 3b equals 4, and b is
4/3.
4/3. Or 1.33 repeating. Okay, which means we can find c. A squared plus b squared equals c squared, and 4 plus 1.33 squared, which is going to give me
52 over 9, and then we're gonna square root it.
good. Well, 4 plus 16 over 9, right? That it was 52, you said?
If I didn't mess up.
Because 4 times 9 is 36, and 36 plus 16 is 52 over 9. Very good. And then what is the square root of that number? You get 2 square root 13 over 3. Which is 2.4. What a good old time there, huh? Well, now you know A, and now you know B, and now you know C. So let's go ahead and plot them all. And that means I go up 2.4, 1, 2, 1, 2.4. That's going to be real close. Let me move that out the way. 1, 2, and then 0.4. Same thing here. 1, 2, and then the 0.4. So focus 1, vertex 1, vertex 2, focus 2, and then B, I go out 1.33, 1.33, 1.33, minor point, and then connect fundamental rectangle. And we open up. Down. Okay. And all we need is the equation and everything else labeled, which is perfect. So we had x minus 1. Actually, no, it starts the other way because it opens up. Y plus 1 squared over 4 minus x minus 1 squared over, ooh, yeah, this is going to be fun. So b is 4/3. B squared is 16 over 9 equal to 1. Now, I don't think you can leave it like that. So you have to reciprocate it and get y plus 1 squared over 4 minus, didn't reciprocate it, minus 9 times x minus 1 squared over 16 equal to 1. Okay, and then label everything we have.
So you don't have to divide off that 9?
No, because if you do, then you'll just be back here. So you might be able to leave it like this. If not, it's going to be the one I boxed. Vertices are 1. And if you went up to, no, it gave us the vertices though, right? So 1, 1, and 1, 3, 1, negative 3. Foci are ugly, so it's going to be 1 and negative 1 plus or minus 2 square root 13 over 3. And then minor points, ugly as well. It's going to be 1 plus or minus 4/3 and negative 1. And they give us the asymptotes already. Okay, y'all. And those are hyperbolas, which, again, shouldn't seem too crazy because just like ellipses, if you know A, B, C, what axis you're parallel to, then everything should work out. Hyperbolas. Let's see. Where'd you go? There you are. Hyperbola. Ooh, okay, yeah. Perfect. Okay. Other than that, we are done. So if you have any questions, please ask. Any homeworks, questions, please ask. If not, and you're good, then I will see you on Thursday.
Sir, why would you choose this problem? It was so ugly.
Makes you think.
Yeah.
Not
Yeah.
everything could be pretty. Well, to me, fractions are pretty, so this is a nice looking
Well,
problem.
yeah.
You got
No,
to
this
find
is
definition
not
of
that
pretty.
bad, but I mean,
My pretty and your pretty, Ethan. Totally different, okay? 1325. There we go. Announcement, modules. Bye. She said bye. How would we use this in real life? True that. Well, if you're going to take Cal 2, you're going to use it again. Other than that, nowhere else.
If you become a math teacher, professor,
Yeah, if you
or
become a
engineer,
math teacher, you'll use it again.
or an engineer, or I think that's it.
Maybe that's it. How's it applicable? What are hyperbolas actually good for? What is one good example? They can use them to find what is
Astrophysics.
it? No, like say if what was one good example? Like say if they're trying to like triangulate where a bomb went off, like in a war zone, they can do that by using hyperbolas. Hyperbolas can pinpoint what is it? Because I think they do it by sound.
like distance of sound.
Yeah, like distance of sound, they're able to pinpoint where like something catastrophic has occurred, or not even catastrophic. It could be just like find out where, like if there's something making a loud sound in some area, that hyperbola can pinpoint exactly where that object is. Other than that, it's iconic, it's geometrical, it's heavily algebra based, so just a bunch of practice.
So I feel really stupid asking this question, but this is why I'm having so much problems with hyperbolas and ellipses.
Mm-hmm.
Is it just memorizing like which one B goes to, which one A goes to, and which one C goes to? Because I keep having to look back every single time I try to do a problem.
Well, when you come to ellipses, I guess one of the big parts, because remember that if you know A, B, and C, like A is the distance for the vertex, B is the distance for minor points, and C is the distance for foci. But I guess it comes down to what what it comes down to for ellipses is what axis you're parallel with. Because if you're parallel with the y-axis, this means that when you write your formula, that y is going to have the denominator of a squared instead of x. Because normally it's x squared over a squared plus y squared over b squared equal to 1, but that's if you're parallel with the x-axis. If you're parallel with the y-axis, it becomes x squared over b squared plus y squared over a squared equal to 1.
Right. Okay. So it's
So-
it's more just it's more for me. The problem is just remembering what A is the distance from this, B is the distance from this, C is the distance from this. Like I said earlier, remember I asked you, I'm like, is A was going to be for B? I thought no, C was the distance from the center to the vertex, and then you said no, it was still the
It's still A. Yeah.
But like, cause I keep getting like confused every time they change axes. Same thing for
But
ellipses.
I mean, no matter what axis they're parallel to, they still have the same meaning and definition. So no matter if you're parallel with the x or y axis, A is still distance to vertex, B is still distance to minor point, C is still distance to foci. That's it.
So it would just be like flipping the